So we are looking at joint distributed random variables. Okay, so this is just an extension of or a combination of what we are doing. So if you have a discrete, instead of having just x, you're going to have x and also y values. So if it's in calculus, you're saying a double a function of two variables. This is just the same. So we first look at joint discrete. Joint discrete distribution. So earlier on we had a function of this nature. X is equal to x. So this was not joint. But now I want to look at a function of this nature. X, y. The probability that x is equal to x and that y is equal to y. So we have something like this. So that is for all values of x and y. That's how we define a joint probability density function for discrete. We also have properties like one in terms of the theorem, where we have a function f of xy is the joint. It's a joint PDF of x and y if and only if it satisfies the following. One, f of xy is greater or equal to 0. That is for all x and y. Two, the sum of all x, sum of all y of this very function should be 1. So just the same as we are doing in a single variable. So we still have the same properties. So here we have a new concept of the marginal. So if you have the pair xy of discrete a random variable with joint probability density function f of xy, then the marginal probability function of x and y are given by, so we have two of them. One, you pick for f of x, so we get the sum of all y f of xy. If you want the marginal for y, we pick the sum of all x of the function fxy. Okay, so that is respective. So if you want the marginal for x, you get the first one. The marginal for y, you get the second one. Okay, then next thing, it will be the CDF. The CDF of X and Y is defined in the same way we are defining on the single one, except now we are having two variables. So we'll be taking X less or equal to X, also Y less or equal to Y. What else do we need to know? The properties of the CDF. So the CDF, so we are saying if f of x, y is a CDF, then you expect to have one, the limit as x goes negative infinite of this f of xy should be the same as the limit as y goes to negative infinite of f of xy, and they should give us 0. I mean of the margin of the CDF. So we need the CDF here. The CDF here. Okay. Then if this goes to positive infinite, it should be the same as this guy goes to positive infinite. Then we should get 1. Then what about independence? So I'm saying if x and y are independent, then f of xy will be equal to the product of the marginal. So this is the same as the sum of OY, f of xy, the sum of OX, f of xy. Because we are saying that's how we are defining the marginals. So let's look at the examples. So the examples, okay. The first one, we look at the joint PDF of X and Y is given by, so the same idea of the table if it's discrete. So we have a table so this is X, then we have f of xy, and then we have y. So except for y, let's make it a bit big. For y, we have 1, 2. For x, now we have 0, 1, 2. So the corresponding 0.1, 0.2, 0.3, 0.2, 0.1, 0.1. So these numbers here mean that if, for example, we have f of 0, 1, then it's going to be 0.1 when x is 0 and y is 1. So it's like the multiplication table. So let's see A, find the probability that x is less than y. So the probability that x is less than y is just the same as doing what? Getting the sum of all xy with a condition that x must be less than y of the function f of xy. So let's start. So the first one is going to be f of 0, 1, x is less than here, plus f of 0, 2, again x is less than, plus f of 1, 2. These are the only possibilities where x will be less than y. If you try 1, 1, they will be equal. 2, 2, they will be equal. 2, 1, x will be greater. So what is f of 0, 1? We get 0.1. f of 0, 2, 0, 2, we get 0.2. And f of 1, 2, we get 0.1. So the sum becomes 0.4. So it must be a nice thing to do.
I didn't get it.
Okay.
Yeah.
So we want to look at, we are looking for the probability that x will be less than y. And how we find that probability is, remember this is discrete. So for discrete, we sum. So because we add for discrete, our task now is to look at, from our table, you should pick x less than y, the points that are going to use. So here we only have, for x we have 0, 1, 2. For y we have 1, 2. So which pairs here will have a combination of x and y, but x is less than y in each pair? So if we pick 0 and 1, this one here, x, y. So x is 0, y is 1. So 0 is less than 1. X is 0, y is 2, 0 is less than 2. So we'll pick these points, 0, 1, 0, 2. Then we got the next one. X is 1, y is 1. They are equal. So we leave that one out. X is 2, y is 1. X is now greater than y. So we leave that one out. X is 1, y is 2. 1 is less than 2. So we pick 1, 2. 2, 2, they are equal. So we leave that out. So now we want this. And since this bit we are summing, we will get the values of this. So f of 0, 1, that's going to be x 0, y 1. What do they give us? So where they meet is what we get, 0.1. So keep following them like that until we have 0.2, 0.1, and then get the sum.
Okay, so it's fine now.
Okay, then B, we want to find the marginals find fx, find fx of x and fy of y. So we want to find a marginal. So let's start with the margin of x, x. Now, by definition, we say this is the sum of all y getting f of x1. Now, to do that, which one is our y here? So our y, we have 1 and we have 2. So get the sum of y from 1 to 2 of the function f of xy. So we'll sum over y values for each x value. So when we say f of x1 plus f of x2. So what does this mean? So you're going to pick, let me see, have I reversed it? It's the same thing that I mean. So when we take, let's see, it's supposed to be f of, the x variables should appear as x variables. Okay, so we have f of, so what are the x variables that we have? We have 0, so pick 0 and pick OY. We also pick 1 and pick OY. We also pick 2 and pick OY and get the sum. Okay, that is f of 0y, that is f of 0, 1 plus f of 0, 2. So when you pick 0, you follow the whole line for y. Plus you got 1, 1 being x, 1 comma 0 plus, 1 comma 1 because y doesn't have 0. So you pick 1 comma 1 plus f of 1 comma 2 plus we now go to 2 for x, 2 comma 1 plus 2 comma 2. That is 0.1 plus 0.2 plus 0.2 plus 0.1 plus 0.3 plus 0.1. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if we are to pick that sum, it's giving us 10, which is 1. So this is just verifying that this is the full MGF if you sum it across. But then how do you present our answer? So present our answer in pairs. So this, this, F11, and also this. So that means that we won't have to add them, so just have to format a table of values. So we have x value and the marginal. So when x is 0, when x is 1, and when x is 2. So when x is 0, we are adding the f of 0 plus the f of 02. So f of 01 plus f of 02. So we got 0.1 plus 0.2. This would be 0.3. Then we got 1, 0.2, 1, 2, 0.1. So again, we have another 0.3. Then you go to 2, 0.3, 0.1. So we have 0.4. So you leave your marginal in this form. So that if you are to sum the whole marginal from this property, if you are to sum the whole marginal, you must get 1. So these, when you pick for OY or for OX, they must give you 1. Then you know it's correct. So let's also find FYY. So this is the sum of OX, f of x, y. That is f. So you look at our x, y. So now we're looking at x, and then we have y1. We also have f, x, then we have y2. So when we pick f of y, when y is 1, in that sense, that is the sum of all x, x starting from 0, x starting from 0 to 2 of f of x1, which is f of 01, f of 11, f of 21. So what is f of 01? So f of 01 is 0.1. F of 11 is 0.2. F of 21 is 0.3. So the sum is 0.6. We also pick 2 here. That is the sum again of OX, f of x 2. That is f of 02, f of 1, 2, f of 2, f of 1, 2, f of 2, 2, 2. So f of 02, 02, that's 0.2, plus f of 1, 2, 0.1, plus f of 2, 2, 0.1. So again, here we get 0.4. So to present our answer, we present it nicely in a table form. So this is y, and y has 1, 2, and this will be fyy. That is for 1, 0.6, for 2, 0.4. So this is the marginal. Then there's a question C. Are x and y independent? Are x and y independent? So what did we say about independence? So we said if f of xy is equal to f of x, and f of y, then the two are independent. So let's pick a sample, because for testing, for discrete, we have to pick point by point to show the equality. So let's see. If we pick 0.1, then here we must pick it in which sense? We must pick it in the discrete sense. So it must f of x 0 and f of y 1, like that. Because we have found everything. So f of 0, 1, f of 0, 1, it's here, 0.1. So this is 0.1. What about f of x 0? F of x 0, so this was the part, f of x 0 was giving 0.3. So we have 0.3 multiplied by f of y1. F of y1 is 0.6. So these two are not equal. So because they are not equal, x and y are not independent. So you could pick endpoint. You could pick 1, 2 and see if it's the same as f of x1, f of y2. The good part is that you have f of x1. So f of x1 was the second part, 1, 1. So it gave us 0.3. So we have 0.3 here. By f of y2, f of y2 0.4. 0.4. So we get, is this the same as f of 1, 2? So obviously not. Let's check. F of 1, 2 is 0.1. 0.1 is by far not equal to 0.3 by 0.4. So we have that. Okay, so before we move to the next question, we'll have to log out and log back, unless we have questions. No question, okay. So let's log out and come back.